Today, we're diving into a really fascinating project called Patchwork OS. It's an experiment that basically throws the entire rulebook out the window to ask some big questions about how our computers ought to work.
So let me start by asking you this. Just imagine for a second, what if your computer had no settings? No control panels, no system preferences, none of that. What if every single thing you did was as simple as just reading and writing to a file?
Now, this isn't just some crazy thought experiment. It's the absolute core philosophy behind Patchwork OS. The idea's been around for a while. It has roots in older systems like Plan 9, but this project takes it to a whole other level. So what does everything as a file actually mean when you're using it? Well, the concept is as radical as it is simple. Your keyboard, it's not some abstract thing hidden behind a driver. Nope, it's just a file that you can read from. Your network connection, it's not buried in some menu. It's a directory full of files you can interact with directly. Every single part of the system becomes just another block you can play with in the file system.
You can really see the difference right here. On one side, you've got your typical operating system. It's this complex mess of files, devices, special APIs, and a million different settings panels. And on the other side, Patchwork OS just sweeps all that complexity away. It's all unified under one single consistent idea. It's just files.
So how in the world do you build something so fundamentally different? Well, you have to start at the very core of the system, the kernel. And Patchwork OS approaches its kernel design kind of like a giant set of Lego bricks. See, instead of one giant monolithic kernel that tries to do everything all at once, Patchwork OS breaks it up into these small independent modules. And here's the really cool part. These modules can be loaded and unloaded while the system is running. The kernel can literally rewrite itself on the fly, adding or removing features as it needs them. And this modular approach, it's got some huge perks. For developers, it makes working on the system incredibly convenient. But for the system itself, it saves a ton of memory because it only loads the drivers for hardware that's actually plugged in. The design is so baked in that any new part of the system, like for USB ports, can just plug right into this dynamic loading system. It's super flexible. Okay, so we've got the theory down, a simple file-based philosophy and this modular Lego-like kernel. But what does this actually look like when the rubber meets the road? Let's take something we all do, like setting up a network, and see how it works here. We're going to walk through a real example from the project's own documentation to see this everything as a file idea in action. And just a heads up, this is probably going to look a little different from anything you've ever seen before.
All right, let's break this down. First, to create a network socket, you don't call some complicated function. You just open a file. That's it. The system then creates the socket, and as you can see in step 2, you find out its ID by just reading it from that file. Let's say it gives you the number 5. Next, you want to turn this into a server? You just write a simple text command, bind my server, and listen to a control file. And finally, to accept a connection on that server, you guessed it, you just open another file. The whole thing is done with nothing but basic file operations. I know what you might be thinking. That looks a little strange, right? Maybe even a bit clunky compared to how we do it now. So why on earth would you design an entire operating system around this way of doing things? And this is the payoff. It's all about a really powerful idea called composability. Because everything is a simple, universal building block, a file, you can combine them in ways the original designers never even dreamed of. Think about it. In a normal OS, if you want to wait for a few different things to happen at once, you might need a special, complicated bit of code. But in Patchwork OS, you can just use a standard tool that already knows how to watch multiple files. You get really complex behavior almost for free. Okay, so this philosophy is elegant, for sure. But we have to ask the big question. How does it actually perform? I mean, it's one thing for an experimental project to have a clever idea, but how does it stack up against an absolute titan like Linux?
So we have this beautiful theory of radical simplicity, but does it just crumble under real-world pressure? Well, the project decided to put it to the test.
So here's the setup. The test is a memory allocation benchmark. The task is simple. Map and unmap a bunch of memory pages over and over again. In one corner, we have Patchwork OS. In the other, a standard installation of Fedora Linux. The metric is time, and remember, lower is better.
And the results are, honestly, they're shocking. In this specific test, Patchwork OS isn't just a little faster, it is more than 5 times faster than Linux. Now, to be fair, the developer is quick to point out this isn't a perfect apples-to-apples comparison. But still, a performance gap that huge is just staggering.
So how is that even possible? Well, it comes down to a really clever and unconventional design choice. Instead of storing information about memory in one place and the memory map somewhere else, Patchwork OS embeds that info directly into the map itself. This means the CPU doesn't have to go looking around for it. The data is right there, which leads to fantastic CPU cache performance and means the whole operation takes about the same amount of time no matter how much memory you're dealing with.
A victory and a performance benchmark is exciting, for sure. But beating Linux was never the goal here. To really understand Patchwork OS, you have to look at why it was even created in the first place.
This really reveals the true heart of the project. It was never meant to be a Linux killer. It's an educational tool. It's a playground to experiment with unique, unproven ideas instead of just doing what everyone else has already done. And maybe most importantly of all, it's a project built for the sheer joy of it.
The developer offers this really beautiful and humble reflection. The value here isn't about reaching some final, polished product. The value is the journey itself, the learning, the experimenting, the process of just building something new to see what happens. The experiment is the entire point.
And that kind of leaves us with a final thought, doesn't it? In a world that's so focused on production-ready, market-tested products, projects like Patchwork OS are this powerful reminder of the importance of just being curious. It makes you wonder, what other radical ideas are out there, just waiting for someone to explore them, not for profit, but just for the fun of it.